In June 2024, an independent radio astronomy consortium published raw data that should have been global headlines. "47 luminous events distributed along 8,200 kilometers over the South Pacific, captured between March and August by the 3I Atlas orbital surveillance system. Pulses of blue-green light, each lasting about 90 seconds, repeating with almost mechanical precision every 11.3 days. Meanwhile, the International Atmospheric Monitoring Agency withheld its official analysis, claiming only extended methodological review. No press conference. No technical statement. Institutional silence in the face of a phenomenon that challenges 3 decades of space meteorology. What exactly is being reviewed for so long? High-altitude lightning, red sprites, blue jets, all are explosive and fleeting events. But these pulses maintain a stable brightness for over a minute, and they don't appear randomly. They follow a schedule. They occur in predictable locations. They emit light in a specific spectral range, between 480 and 520 nanometers, the visible blue-green region. If you subscribe to this channel now, in the next 15 minutes, I will show you why this pattern violates everything we know about natural phenomena, and why the next cycle, scheduled for October 27th, may force the scientific community to admit that something is fundamentally wrong with our assumptions. It's the distance between New York and Berlin, but traced over one of the planet's most remote stretches, where the South Pacific meets deep currents and unstable terrestrial magnetic fields. The 47 mapped events form an almost perfectly straight line along latitude 34.7 degrees. Not a chaotic dispersion, not an arc following high-altitude winds or ocean currents, a line. The observed angular precision is below 0.4 degrees. For context, natural thunderstorms generate lightning that disperses at angles of 5 to 15 degrees, depending on wind shear and thermal gradients. Here, the margin is 15 times smaller. This is the typical tolerance of satellite-guided positioning systems, or geodetic triangulation lasers. "11 days is enough time for weather systems to traverse entire hemispheres, for ocean currents to displace billions of tons of water, for the Earth's magnetic field to undergo unpredictable solar fluctuations. Yet these pulses return like a Swiss watch. probability of a natural phenomenon maintaining this cadence and this geometry over 6 consecutive months is less than 1 in 10,000, according to atmospheric turbulence and geomagnetic dynamics models. We are not talking about acceptable statistical coincidence. We are talking about something that demands an explanation. The average duration of each pulse is 90 seconds, 1.5 minutes. It seems short until you compare it. A typical lightning strike lasts about 1/5 of a second. A red sprite, those rare phenomena that occur above severe thunderstorms, persists for perhaps 2 to 3 seconds. Orbital re-entries of space debris, deactivated satellites, abandoned rockets, generate luminous trails that last between 5 and 15 seconds as the object burns up in the atmosphere. 90 seconds is an eternity in terms of high-energy transient phenomena. To sustain continuous luminous emission on this scale, you need a constant energy source and a material reservoir that doesn't deplete instantly. What, in the middle of the South Pacific, 100 kilometers high, could do that? The first independent validation came from the Andean Radio Observatory, located in northern Chile, almost 4,000 kilometers from the epicenter of the corridor. Its radio telescopes detected X-band emissions during 3 of the events recorded by 3i Atlas. X-band is the range between 8 and 12 gigahertz, used for satellite communication and high-resolution weather radar. What is interesting is that natural emissions at this frequency, such as atmospheric electrical discharges, are typically erratic, with sharp peaks and drops. Here, the emissions showed smooth, almost sinusoidal modulation throughout the 90 seconds. "The signature is too clean," said Ramiro Valdez, a radio astronomer associated with the observatory. "It looks more like a communication carrier than geophysical noise." Its spectrometers confirmed the dominant spectral range between 480 and 520 nanometers, but detected something additional, a second faint line around 630 nanometers, associated with excited atomic oxygen. This type of emission occurs during polar auroras, when solar particles collide with atoms in the ionosphere. But the South Pacific corridor is at mid-latitudes, far from auroral zones. Furthermore, the current solar cycle was in a phase of minimal activity during the months of observation. There were no significant geomagnetic storms during that period. So where does the energy come from to ionize atmospheric oxygen in such a localized and repetitive way? Its infrared sensors captured thermal signatures during at least 2 of the events. The estimated brightness temperature ranged between 1200 and 1400 degrees Celsius. This is hotter than fresh basaltic lava, but well below orbital re-entry temperatures, which can exceed 3000 degrees. The thermal range is consistent with controlled chemical combustion or high-voltage electrical discharge in atmospheric plasma. But, again, the duration. Maintaining this temperature for 90 seconds requires a considerable energy reservoir. It's not something you get from a lightning strike or a disintegrating meteor. Now, let's look at the escalation of anomalies, because this is where the phenomenon begins to look less natural and more orchestrated. When light is emitted by chaotic natural processes, such as electrical discharges or combustion, it tends to be unpolarized, meaning the electromagnetic waves vibrate in all possible planes. But polarimetric analysis of the detected pulses showed a degree of linear polarization of around 35%. This means that more than a third of the light is vibrating in a single preferred plane. You see this in lasers, in light beams reflected by metallic surfaces and optical crystals, not in turbulent atmospheric phenomena. The orientation of the polarization plane, moreover, remained constant across multiple events, always aligned with the local magnetic axis, as if whatever was generating the light was sensitive, or responding, to Earth's geomagnetic field. Storms, submarine volcanoes, seismic events all generate energy patterns that vary according to terrain topography, atmospheric density, and local winds. You would expect pulses separated by hundreds of kilometers to exhibit variations in intensity, duration, and spectrum. But the data shows a standard deviation of less than 8% across all main parameters: duration, peak intensity, spectral width. It's as if each event was a near-perfect copy of the last. In atmospheric science, this level of uniformity is statistically implausible without some mechanism for feedback or centralized control. Low-orbit satellites take about 90 minutes. Geostationary orbits are fixed relative to Earth. 11 days corresponds to no stable orbital period, nor to terrestrial geophysical cycles. It's not the tidal cycle. It's not solar rotation. It's not the precession of magnetic fields. It's an orphan number without obvious natural context, but it is persistent. 47 events over 6 months, all fitting within this interval with a margin of error of less than an hour. This demands synchronicity. Preliminary analysis detected ionized vapor with a calcium to sodium ratio 12%, above the catalog standard for orbital reentries. When satellites or rockets burn up in the atmosphere, they release metals characteristic of their structural alloys: aluminum, titanium, copper, traces of calcium and sodium. These proportions have been known and tracked for decades by space debris monitoring programs. A 12% deviation might seem small, but in high-precision spectrometry, it's a red flag. It means the material source is different. It could be a meteorite with an atypical mineral composition. It could be volcanic ejection from a deep submarine vent, bringing up minerals from the upper mantle. Or it could be something manufactured with an unconventional metallic alloy. The South Pacific is monitored by dozens of ocean floor seismographs, part of tsunami warning networks. During the period from March to August, no seismic event above magnitude 2.0 was recorded in the corridor. No substantial mechanical energy release. This rules out submarine explosions, caldera collapses, lava ejections. Whatever is generating the luminous pulses is neither moving rocks nor generating detectable shockwaves. Whatever is generating the light pulses is not moving rocks or producing detectable shockwaves. Charged particles, protons, electrons, tend to follow these lines like beads sliding along a wire. During geomagnetic storms, auroras appear along these lines at polar latitudes. But this phenomenon is occurring at mid-latitudes and without an associated solar storm. Furthermore, the angular precision is anomalous. Geomagnetic drift, ionospheric turbulence, local field variations, all of this should disperse any natural phenomenon. But it doesn't. The events remain glued to the line, as if they were being actively guided. All 47 events occurred between 02.15 and 04:45, coordinated universal time. This means local pre-dawn hours for the South Pacific. The ionosphere is more stable at night, with less turbulence induced by solar radiation. If something were attempting to minimize atmospheric interference, it would operate precisely within this window. But natural phenomena do not choose times. Lightning occurs when electrical charge conditions are met, day or night. Volcanoes erupt when magmatic pressure exceeds crustal resistance, regardless of the clock. This hourly preference adds another layer of strangeness to the pattern. First hypothesis, submarine volcanic outgassing. The idea is that deep fissures are releasing superheated gases, sulfur dioxide, water vapor, methane, which, upon reaching the surface, combust on contact with atmospheric oxygen. The problem? Outgassing is a continuous or sporadic process, not cyclical with minute level precision. Furthermore, volcanic plumes generate ash clouds, alter local ocean chemistry, and release massive amounts of CO2 detectable by satellites. None of this has been observed. The ocean surface remained thermally stable. There were no pH or turbidity anomalies in the waters. Massive outgassing leaves a trace. This phenomenon does not. The problem? Re-entering objects follow predictable ballistic trajectories, determined by gravity and atmospheric drag. They do not return to the same geographical corridor repeatedly, and certainly not every 11.3 days. Furthermore, re-entries are unique events. The object burns up and disappears. There's no way to have 47 identical re-entries in the same location, unless someone is deliberately dumping debris, which would be detected by military space surveillance systems. Perhaps the 3-eye Atlas sensors are misinterpreting solar reflections, electronic noise, or interference from terrestrial signals. But remember, 3 independent systems, radio telescopes in Chile, spectrometers in Tenerife, and a commercial infrared satellite, confirm the events. Different sensors, different technologies, different geographical locations. Instrumental error does not replicate itself in this manner. It would require a coordinated systematic failure, which is absurdly improbable. Instrumental error doesn't replicate this way. It would require coordinated systematic failure, which is absurdly improbable. In theory, extreme density gradients in the air could focus light from distant sources, creating luminous mirages. But atmospheric lenses are unstable, lasting seconds, never minutes. And they don't explain the infrared thermal emission, which requires a real heat source, not an optical illusion. Nor do they explain the X-band radio emissions. Mirages do not generate electromagnetic waves at multiple frequencies simultaneously. One possibility, which no one wants to be the first to suggest at a peer-reviewed conference, is that the pulses are vestiges of an undeclared technological experiment. Military orbital systems with long-duration thermoelectric batteries, designed to release energy in regular cycles as part of a communication or positioning test. The temporal precision, spatial uniformity, light polarization, and correlation with magnetic fields, all of this would be consistent with a designed device, not a natural process. But this raises political questions. Which nation would operate something like this without international notification? And why over one of the planet's most remote regions? Perhaps the remnants of a past interstellar probe, temporarily captured by Earth's gravity decades or centuries ago, now in a degraded orbit, releasing residual energy as electronic components cyclically fail. This would explain the regularity, the atypical material composition, and the absence of seismic activity. But it would require us to believe that something like this went unnoticed by all 20th and 21st century space tracking systems, which is difficult to swallow. A third, more cautious approach suggests we are facing a rare geophysical phenomenon, not yet documented in scientific literature, something related to the interaction between deep ocean currents, Earth's magnetic fields, and atmospheric ionization, generating semi-regular plasma pulses. But this would require an extremely precise feedback mechanism, almost like a natural oscillator. Nature does have oscillators, tidal pendulums, orbital resonances, climate cycles, but rarely with the stability on timescales of days. Whatever the answer, the institutional layer adds tension to the narrative. The Independent Radio Astronomy Consortium published the raw data in an open repository, following standard scientific protocol. Total transparency. Any researcher with access to analysis software can download the files and verify the numbers. But the International Atmospheric Monitoring Agency, which has an official mandate to interpret anomalous high-altitude phenomena, has remained silent. They received the same data in April. Two months before the public release. And since then, only vague statements about extended methodological review. No preliminary paper, no technical conference, no briefing for the specialized press. Okay, no preliminary papers, no technical conferences, no specialized press briefings. Others speak of signs of extraterrestrial intelligence. Most discussions lack rigor, but the public is not to blame. It's the absence of official communication. When institutions that should be leading the analysis remain silent, amateurs fill the void. And the longer it goes on, the more the narrative slips out of scientific control. Three commercial multispectral imaging satellites have been repositioned to point at the corridor during the predicted 8-hour window. Ground-based telescopes in Chile, Australia, and Madagascar will be coordinated for simultaneous triangulation. If the pulses occur again, we will have data of unprecedented resolution, high-definition spectroscopy, continuous thermal imaging, precise measurement of polarization and temporal modulation. This forces us to definitively discard instrumental error hypotheses and to seek deep physical explanations. If the phenomenon does not occur, we have two possibilities. Either the cycle ended naturally, suggesting a geophysical process of limited duration, or someone, realized it was being observed and shut down the system. Both conclusions are disturbing, each in its own way. Preparation for the October observation window involves unprecedented coordination. Amateur astronomers have been called upon to monitor the corridor with personal equipment. Data will be aggregated in real time via an open platform, allowing anyone with a modest telescope to contribute. It is citizen science on a global scale, driven by the urgency of the moment. Because if we miss this window, the next cycle would only occur in November, and no one knows if there will be a next cycle. Commercial satellites need to deviate from standard routes, which costs propellant and shortens operational lifespan. Ground-based telescopes are canceling scheduled observations of exoplanets and distant galaxies to focus on the South Pacific. Radio telescopes are being reconfigured to sweep specific frequency bands. All of this has a financial and political cost. Institutions need to justify the diversion of resources, and justifying requires publicly admitting that something inexplicable is happening. Which, until now, many have been reluctant to do. If it is natural but rare, we need to update atmospheric and geophysical models, incorporate this type of event into space weather simulations and communications interference forecasts. If it is something in between, a hybrid of natural and artificial, like extremal microbes interacting with electromagnetic fields in unexpected ways, for example, then we are facing an entirely new scientific frontier. Hybrid between natural and artificial, like extremophile microbes interacting with electromagnetic fields in unexpected ways, for example, then we are facing an entirely new scientific frontier. It is the possibility that it is natural, yet we have no idea how it works, because that would mean that after decades of satellites, weather balloons, global monitoring networks, there are still fundamental Earth processes that completely elude us. Processes capable of generating energy regularly in specific locations with a precision that rivals human instruments. And if that's possible here, what else is happening in less monitored regions? At the bottom of the oceans, in remote deserts? In the upper layers of the atmosphere that we rarely look at? And if you want to follow the results of the October 27th observation firsthand, subscribe to the channel and turn on notifications. I will publish a detailed analysis as soon as the data is available. Open data allows thousands of brilliant minds around the world to contribute, find patterns, propose tests. The Radio Astronomy Consortium did its part by publishing everything. Now the pressure is on official agencies to do the same. Methodological review is important, yes. But 6 months is more than enough time for preliminary analysis. Prolonged silence does not protect scientific credibility, it erodes it. Or they might appear and turn out to be something perfectly mundane that we simply hadn't cataloged before. Perhaps a new form of high-altitude lightning with different dynamics. Perhaps an interaction between cosmic particles and oceanic aerosols under rare conditions. Science is full of mysteries that, once solved, become chapters in textbooks. 20 years from now, space weather students might be learning about Pacific pulses as a known and understood phenomenon. That the October data confirms something that forces a deep revision. That the numbers don't fit any existing model. That we need to admit something observed Earth interacted with our instruments and then left. Or that it's still here, operating in a layer we rarely perceive, leaving only luminous signatures like footprints in cosmic sand. Those 90 seconds of blue-green light over the South Pacific might just be that. A pause, a whisper in the void, a question asked in a language we are still learning to decipher. Or perhaps it is nothing. Just another reminder that, however much we have learned, the planet beneath our feet and the sky above our heads still hold deep secrets, waiting for the right moment to emerge into the light.